We need to solve each of these equations in the interval from 0 to 360. So first off, we've got sine 2x plus cos x equals 0. Now, this sine 2x there, I know I can rewrite that with the sine double angle formula, which is 2 sine x cos x. Then I've still got the plus cos x there, and that needs to equal 0. Next, I noticed that I could factorise cos x outside. So factorising the cos x, I get left with the 2 sine x plus 1. So just to be super clear, we've got this times this is this, and this times this is this. Now that it's been factorised, I can say that either the cos x equals 0, or the sine x equals minus 1/2. I know that cos equals 0 at 90, or if you wanted to, you could do cos inverse of 0, and you get 90. Just to draw a quick cos graph to find the other solution for where it's equal to 0. So I know cos is equal to 0 at 90, or at 270. For the second solution, if I do sine inverse of minus 1/2, I find that I get minus 30. Draw a quick sine graph. Going down to include the minus 30 here. So I had one solution here, there'll be another solution here, and another solution here. I know that's 30, so this is going to be 30. So that's going to be 180 plus 30, which is 210, or 360 minus 30. Therefore, my four solutions to this equation are the 90, the 270, the 210, or the 330. The minus 30 is outside the range, so we're not going to include that. Next, we're going to do 2 cos 2x equals to 7 sin x. Now, I know there are 3 different versions of the cos double angle formula. Let me write them down at the top here just to remind you. We know cos 2x is either cos squared x minus sine squared x, or it is 2 cos squared x minus 1, or it is 1 minus 2 sine squared x. In this case, considering we've got a sine x over there, I think this is probably the best option for me to replace the cos 2x with. So that's what I'm going to do. So I've got 2 lots of the cos 2x, so 2 lots of the 1 minus 2 sine squared x. Expand these brackets. Moving everything onto one side. And factorising. Or you can use quadratic formula if you prefer. So I know that sine x is equal to 1/4, or sine x is equal to -2. Now I know that there are no, so sine cannot equal -2 if x is a real number, so we'll ignore that. We will do sine inverse of 1/4, which gives me 14.5 degrees. Draw a quick sine graph to get the other solution. So these are my two solutions when sine equals 1/4. I know that's 14.5, so this here is going to be 180 minus 14.5, which is 165.5. So these are my two solutions for that question. And then finally for part D. Let's have a look at part D and create just a bit of space. Again, we've got a cos double angle here. So it's going to be one of these three identities that I'm going to use here. Now, considering in this question, I've got a cos x over here. So this time, I think I'm probably going to use this identity because that's also only in terms of cos. So let's do that. So I'm going to replace that cos x with 2 cos squared x minus 1. Expand the brackets. Put everything onto one side and collect up like terms. We will now solve that. I don't think that's going to factorise very nicely, so let's use the quadratic formula for that. So minus b plus or minus the square root of b squared minus 4ac divided by 2a. So I find that cos x is either 1.74 or 0.096. There's no solutions when it's greater than 1, no real solutions for that. So the only solution would be when cos x is equal to the 0.096. So we'll do cos inverse of that, which gives me 84.5 degrees as one solution. Draw a quick cos graph for the other solution. So my first solution was here, there'll be another solution there. I know this is 84.5, so this is 84.5. So if I do 360, take away 84.5, I get 275.5. And those are the two solutions to that equation.